Hi, welcome to this description of a project I built with Jan Fecho to graph values on a number line or a Cartesian plane. We started out with being able to do number lines, either horizontal or vertical. This is where you would choose it. And these are the values that can be set to determine the bounds of those number lines or Cartesian planes. These have to be set a little carefully. Right now, if you put something that doesn't make sense, there's not a lot of error checking. The nice thing about this is that if you want to put your origin somewhere other than the center of the screen, this allows you to do it. For example, I can move my origin over here by setting my minimum x value and minimum y value and redrawing the plane. Now if my graph is more over here, it'll be easier to see it. When we draw a number line, it helps to set the axis you're not using to 1 and -1 when we draw a number line so that we don't get a lot of crosshatches here. We could do it the other way. If I wanted to do a vertical number line, I would set my x values to -1 and 1, and then I could draw a vertical number line. I'll show you an example of how the number lines work. If I look at a horizontal number line, I'm going to put these values back. I can go over here and take a look. I've got my variable, my operation, and my value. We've set it pretty solid so that students can only change the operation and the value. I want to do equal, draw a number line, and then set a value. So if I say x equals 5, I can graph it. I can even do negatives and values that are in between the points, so I can do decimals and fractions. When we get to inequalities, we have the ability to do both greater than, less than, or greater than or equal to, less than or equal to, and even a not equal to. So here's a less than -5. Here's a greater than or equal to, let's put it in as 2. And I can put more than one on the graph if I wanted to do a compound inequality. And then even a not equal to, do a not equal to 0. And we see we get an arrow going both ways with an open circle in the middle. On the Cartesian plane, I want to make sure I have the correct values for my maximum and minimum x's and y's. Then I'm going to draw my Cartesian plane, and I can use this block down here to draw a linear equation or to graph a linear equation using the standard form of the equation a times x plus b times y equals c. We use this to plot our x-intercepts and y-intercepts, set turtles there, and draw the line using those turtles. So if I graph this, I've got a lovely line. I could even graph a second equation on the same coordinate plane, and I can see where the two cross. I can do a lot with this from this forward, allow the students to see equations, what they look like, check their work. The code behind it is a little long, but it's not too complex. And one of the most interesting things we did was graph on a coordinate plane, which allows us to graph that line you just saw. We used a term called face, which we hadn't used before, and basically set the heading of two turtles that we set at the x and y intercepts towards each other, and then had them draw a line by going towards each other and past each other. We used a lot of pen down in order to draw the coordinate planes themselves, and we had to really think about how we were going to draw that coordinate plane since we didn't use the patches in the background. And that we used an equation right here. This took us a while to get to. This was how we decided how far we had to draw the lines in between each other based on the size of our screen and based on the size, the minimum and maximum values for the x and y axes. It's lots of fun, learned a lot. Hope you like it.